In this video, I'm going to show you how to use dividing to solve for x. Dividing is used to get rid of numbers next to the x's in general. Now, why would we want to do that? Because we need there to be only one x. Now, what I mean when I say that is right here. If we have the problem 3x equals 6, it mostly looks like our original goal to have x and to have other stuff. However, we wanted to have only x. We want one x. We want just x all by itself. Right here, we have 3 x's. We don't care what 3x equals. We care what x equals. Therefore, we have a number right next to x that's being multiplied times x, which we need to get rid of to solve for x all by itself. So how we do that is we divide. Now, again, the dividing rule is, just like the multiplying rule, basically. When we do it, we have to do everything on both sides. Just like in the multiplying, we can divide by anything we want, as long as we do it to everything on both sides of the equation. So if there were a whole line of numbers in the equation, say we had 3 plus 5 plus x plus 2 equals stuff plus stuff plus stuff, we would have to divide every single one of those by the same thing. But we can do whatever we want. We can pick whatever number we want. Now in this case, you can see down here that I picked 3 to divide by. Now, as you may be catching on by now, I wanted to do that so that it would cancel. Because as you see here, if I divide this side by 3, these two things, 3 over 3, anything divided by itself is 1. So 3 over 3, with the x here, is just the same thing as 1x, which is just the same as x. So you see I went from 1x to x. And then here on the other side, we have 6 and then divided by 3. We had the 6 from the original problem, but we had to divide by 3 because we divided by 3 over here. We had to divide everything on both sides by the same number. So 6 divided by 3 is 2. So then we had 1x equals 2. So just x equals 2 is the answer to this problem. Now, here's another example. Now, right here is our problem. 2x equals 10 minus 3x. Solve for x. Now, when you have multiple x's, like you can see here we have a 2x and we have a negative 3x, we must simplify first. We have to combine those two things. We have to put all the x's onto the same side. We can't just start dividing by 2's or dividing by 3's. I mean, which one would you pick? I'll go ahead and tell you neither of them would work. It would make it simple on one side and confusing on the other. So before we either divide everything by 2 or divide everything by negative 3 here, we have to simplify by using, in this case, by using the adding and subtracting rule that we learned about way up here at the beginning. So remember when we were moving the x's around in this example? We're going to do that same thing down here. So you could do, there are multiple things you could do. You could put the 2x over here, but you could also put this negative 3x to the other side. You can go left to right or right to left. Either one is acceptable. I'm going to take the 3x and try to get rid of that one and put it on the other side because there's a 10 over here. And so basically the stuff is already on the right side, so I'm going to go ahead and put the x's on the left side just because I think that would be the easiest way to do it. So what I did was I added 3x to both sides. Remember, with the addition and subtraction rule, you have to add or subtract to both sides of the equation. So I rewrote that here. 2x plus 3x equals 10 minus 3x plus 3x. Now, why did I choose to add versus subtract? Well, because if you look, the 3x from the original problem that we see here in black is negative. Therefore, the way to cancel it, like we're always trying to do, is by adding. How do you get rid of a negative? A positive. So, we can also see by just negative 3x plus 3x will equal 0x, so nothing. You can get rid of the x entirely. The 10 stays the way it is. We didn't touch the 10. And then over here we have 2x plus 3x equals 5x. So now we have 5x equals 10. Now this problem looks like the last one we had. We have a number next to x, and we only have one x in the problem, instead of multiple x's like we started out, where they're all over the place and it's confusing and bad. We simplified it, and now we've got something that we can deal with by dividing, because we have a number next to the x. So, as you can see, I divided everything on both sides by 5, so that these two 5's here, the 5 next to the x especially, would cancel out. So 5 over 5 is 1, so you have 1x equals 10 over 5, which is the same thing as x equals 2. 10 over 5 is 2. So this is the answer to this problem up here. X equals 2. So again, just to summarize what we just did, we had this problem where we could see the numbers next to x. However, we had to simplify first because there were x's in multiple places. So we used rules we already had to simplify to something that we could use the dividing rule on, where there's just x in one place. We did that and got x equals 2 is our answer.